Okay, so now that we have a ball, we can manipulate our space. We're going to start adding some motion to the system. I'm going to do that by allowing time to advance. So I'm going to build a loop. This will be a while loop, which says that as long as the time, which we'll define in a minute, is less than a particular value, let's say 3 seconds, do all these things. First, let me do a little bit of cleanup. I'm going to get rid of a couple of these balls. I don't need those, so I'll delete. I do want to hold on to Bill. I want to hold on to my floor, so I'm going to comment this out. That's a hashtag, a number sign. In Python, anything after a number sign is not considered executable code. It's just a note to yourself. For example, this is a ball. It's red. I can add comments wherever I like in the code. So I have the single ball now. I would like to update its position as time progresses. Now the ball 1 has a property called POS position. So I can call that. I can say ball1.pos. That's the position of ball 1. I want it to change as time goes on. So I'm going to let it be equal to what it was before, that's the initial position, plus some velocity times some time interval. So this is actually the equation that we've used in physics previously that says the position is equal to the initial position plus the velocity times time. And this will update the position of the ball. There are some things in here I haven't yet defined. So velocity doesn't mean anything. That is not something the program knows about right now, so I need to specify. I'm going to say that velocity is a vector, and I'll start it in the positive y dimension. So this is 1 meter per second upwards, 0 in x, 1 in y, 0 in z. So that is set the velocity of the ball. Then I do need to decide what delta t is. Delta t is the time interval. It's how much time to let elapse between different iterations of this loop. I want that to be pretty small, so I'm going to set that to 1/100th of a second. And then since I am counting t here, all the way up to 3 seconds, I do need a starting value for t. So I'm going to say t equals 0 to begin with. And what I'm doing here is setting initial conditions for the loop. Set the initial conditions. In coding, it's very common to set a whole bunch of initial parameters outside the loop and then to begin to use them within. All right, so inside the loop, I have a vector velocity set. The ball's position will update according to that vector velocity for an interval delta t. And then I do need to let the loop know that time is advancing every time it runs. So I'm going to take that t, which will start at 0, and I'll set it equal to whatever its initial value was, a previous value, plus the interval delta t. So every time the loop runs, t will grow by an amount 0.01 or 1/100th of a second. So advance time. Let's run this and see what happens. The ball is over, to the right of the center. I think, let's see, we started at x, 0, 0. Let me put it in the middle and we'll see what happens. It is now above the center of the system. What's happening is the ball is moving, but it's moving so fast that we can't actually see it, which sounds like I'm making that up. It's just the program is going so quickly. We'll need to slow things down so we can actually visualize the motion of the ball. I can do that in Python by setting a rate inside any loop. This just slows things down. So you specify the number of times the loop is allowed to run every second. I'm setting at 200 right now, which is kind of arbitrary. Slow down the loop to n loops per second, however many you decide to put in there. Since this time advances by 1/100th of a second every loop, that's my delta t, then that means it'll allow 2 seconds of computation time to pass, or simulation time, for every second of the loop. So now we can see the ball move upwards. Let me do one other thing before we move on to the next video. It is kind of nice to be able to track the motion of your objects. So if I go up to the ball 1 where I specify the properties of that object, I'm going to add a trail. So this is make trail equals true. And now when the ball moves, it leaves behind a path that I can follow. All right, you can have fun with this. You can specify different velocity. Maybe mine is moving 2 to the right and 1 up at the same time. You can change the initial position. Of course, you can mess with the color of the ball, whatever you like. You have a lot of control over this universe. Nothing particularly exciting is happening yet. It's very predictable because we haven't yet added any accelerations, but we'll do that in the next video.